Morning precalc fans, how are you on this fine sunny Tuesday morning? Sun's out, gonna start warming up. Things are going in the right direction with the thermometer. That's a good thing. Hope everything's going well for you and your family at home. Today we're going to continue on with our notes that we did yesterday. We're going to talk about the idea of angles between two vectors, Victor. So if we take a look at the two vectors that we have here, we want to draw the two vectors from the same initial position and calculate the angle formed by the two vectors. So if I take a look at vector A, which is 3 on the I and 7 on the J, my vector for this first vector is this. And the second one is positive 2 on the I, positive 2 on the I, which takes me to here, and then negative 3 on the J, which brings me down to here. So what we have is a second vector so this is vector A and vector B. Okay, what we want to be able to do is we want to be able to find the angle formed by these two vectors. Well, if we take a look, what we have created in both cases is a triangle, and that's a right triangle. We can calculate this angle here for A, alpha A, by doing my tangent. The tangent of alpha for A is equal to 7 over 3. And we can take our inverse tangent of both sides. So we can have an inverse tangent of 7/3. So we have the inverse tangent, 7 divided by 3. We get 66.8 degrees. And likewise down here, we can find the same alpha for B. The tangent of alpha B. Now what I would suggest to do is still use positives and just find the angle, because if I throw a negative in there, I'm going to get a different answer. So I can go 3 over 2, because I would have 3 here, I have 2 here. So we can do the inverse tangent of negative 3/2. Second tangent of 3 divided by 2. We get an alpha B is 56.3 degrees. So the angle that's formed by these two vectors, Victor, we can add these two together. 8. We get 123.1 degrees is the angle formed by that. So that's one way of being able to do this. But it's a lot of graphical things that we have to deal with here. So we're going to look to find a different way of being able to find this angle. And it involves the idea of the dot product, which we talked about yesterday. Well, if we take a look at our law of cosines, our favorite law of cosines, we have two vectors here, A and B, that are connected at the tail. And we want to find this angle alpha that is, or this angle theta that's between those two vectors. Well, if I would draw and complete my triangle with a third vector as we did before, even though this is not a resultant vector, if I would draw from B to A, this vector is B minus A, or A, I'm sorry, A minus B. Well, if I take a look at the magnitudes of each one of these, and this is going to get ugly to begin with, but it will clean up real quickly. What we have here is the magnitude of A minus B. Well, this would be A minus B I, or I'm sorry, A1 minus B1I, and A2 minus B2 j. Because A1, or A and B are A1I and A2J, and B is B1I plus B2J. I can subtract these two to give me A1 minus B1I and A2 minus B2J. Well, to find our magnitude, what we have to do is we have to square these. So we have, and we're square rooting it, so we have the square root of A1 minus B1 squared plus A2 minus B2 squared. And then this tells me we have to square this. So what happens here is the radical goes away. So for these over here, I'm not going to do this additional step, but what we're left with is A1 minus B1 squared plus A2 minus B2 squared. Then we have the magnitude of A, which is the square root of A1 squared plus A2 squared. And then we're going to square it, so the square root will go away. So we're left with A1 squared plus A2 squared. That's square rooted, but then we're squaring it. The magnitude of B, is, I don't need that, B1 squared plus B2 squared. And then I'm just going to leave this alone right now. I'm just going to leave this as minus 2 absolute value, or magnitude of A, times the magnitude of B, cosine of theta. Well, what we have here is we have a FOIL mentality. We have A1 minus B1 quantity squared, which is A1 minus B1, A1 minus B1. So we are FOILing this out. So when we FOIL this out, we get A1 squared plus 2 A1 B1 plus B1 squared. And if I FOIL this one out, we're left with A2 squared minus 2 A2 B2 plus B2 squared. And like I said, it starts out a little ugly here, but it will clean up real quickly after this step. And this is equal to A1 squared plus A2 squared plus B1 squared plus B2 squared minus 2 out of magnitude of A, magnitude of B, cosine of theta. And like I said, we now will clean this up because this is a little bit ugly. But if I take a look on both sides of my equal sign, if I subtract an A1 squared, subtract this A1 squared, they go bye-bye. If I subtract off this B1 squared minus B1 squared, they go bye-bye. I subtract off A2 squared minus A2 squared and subtract off B2 squared. What happens is all these terms go away. So what we are left with when we subtract all these off, because these will just cancel out, we're left with 2 A1 B1, I'm sorry, minus, that should be a minus in there, minus 2 A2 B2, and on the right hand side of the equal sign we're left with a minus 2 magnitude of A times the magnitude of B cosine of theta. The last thing we're going to do is we're going to divide everything by negative 2. So what we are left with is A1 B1 plus A2 B2 is equal to magnitude of A times the magnitude of B times the cosine of theta. Well, one last thing to take a look at is this right here. A1 B1 plus A2 B2. What is this equal to? Well, what we talked about yesterday, this is just our dot product. So we have A dot B is equal to the magnitude of A times the magnitude of B cosine of theta. Which now allows us to solve for that angle theta formed by those two vectors. By the more acceptable way of rewriting this is the cosine of theta is equal to A dot B, the dot products of two vectors, divided by the magnitude, sorry about that, the magnitude of the two vectors, Victor. So this will allow us to be able to calculate the angle formed by two vectors, Victor, and I don't have to sit there and draw a diagram out and figure out what the angle is. So if we take a look at a problem, I want to find the angle formed by these two vectors, Victor. What we have to do is calculate these values, and what I tend to do is I tend to do these separately. I just go, well, what is x dot v? What is the dot product here? Well, I need to multiply 4 times negative 2, and then plus the negative, plus a negative 2 times 1. So this gives me negative 8, this gives me negative 2, so this gives me a negative 10. The magnitude of x is just the square root of both of our components squared. So we have 4 squared plus a negative 2 squared. So this gives me 16 plus 4. So we have the square root of 20, and I just leave it like that. I don't worry about simplifying it. The magnitude of v is the square root of negative 2 squared plus 1 squared. So we have negative 4, or positive 4 plus 1, we have the square root of 5. So to calculate our angle, the cosine of theta is going to equal the dot product, negative 10, over the square root of 10, or 20, times square root of 5. And to find our angle, we take the inverse cosine. Now you just have to watch your calculator here. So we have the second, or I can take the negative 10 divided by, whoopsie, 10 divided by a quantity of the square root of 20 times the square root of 5. If I wanted to, I can combine them together to get the square root of 100. So I get a value of negative 1. So I take my second cosine of my answer, and I get 180 degrees. So this angle theta is equal to 180 degrees. Okay, what I want you to do is I want you to turn off your YouTube video and do the second problem here, and then turn it back on and check your answer. So if we take a look at t times t dot x, we have 3 times negative 4 plus 2 times negative 6. So we get 12 minus, or negative 12 plus 12, we get a value of 0. The magnitude of t is the square root of 3 squared plus 2 squared. So we got 9 plus 4, square root of 13. And the magnitude of x is square root of -4 squared plus 6 squared. So we have 16 plus 36, we have square root of 52. So we have the cosine of theta is equal to 0 over square root of 13 times square root of 52. We're going to take the inverse cosine of both sides. So we have the second cosine of 0. When all is said and done, we get 90 degrees. Well, we got two different types of vectors that we can classify these as. We have an orthogonal vectors, Victor, are perpendicular vectors, so we form a right angle. Which these are orthogonal. And this will occur when the dot product is equal to 0. We have parallel vectors. When the angle formed by the two vectors are either 0 or 180 degrees. And these would be parallel vectors, Victor. Okay, what we're going to do is we're going to go to the front side here. And we're going to check our answer that we did here and come down to 123.1 degrees. The two vectors, let's look at our two vectors, A dot B. Let's find the dot product. We have 2 times 3, which is 6, plus 7 times -3, which is -21. So we get a value of -15. So this is 2 times 3, and then 7 times -3. The magnitude of A, once again, I just leave it in unsimplified radical form. We have 3 squared plus 7 squared. So we have 9 plus 49. We have square root of 58. The magnitude of B is the square root of 2 squared plus a -3 squared. So we have 4 plus 9. We have square root of 13. We have the square root of 13 there. So the cosine of this angle theta is equal to -15 over square root of 58 square root of 13 that are being multiplied. Once again, watch your calculators. I typically will just do this first, -15 divided by quantity second square root of 58 times square root of 13. And to close my bottom out, so I have -5.462. And I can do the second cosine of my answer, and we get the same 123.11 degrees. And this is the angle formed by the two vectors, Victor. Now, what you will be able to do is the worksheet I gave you yesterday. The top 3 we're just doing the dot products. The bottom 3 we're doing the angles formed by these two vectors, Victor. What I want you to do is go ahead and complete the worksheet now. It's not a very difficult thing to do. Tomorrow will be a review day. Thursday will be an evaluation over this. And once again, we have one more topic to cover next week, and that will be some polar coordinate ideas. And other than that, we will be done. So please work through this, work through the worksheet. If you have any questions, feel free to ask. Other than that, I hope everything's going well. Miss you guys. Things are going well for you guys. Hopefully that's good. Enjoy some sunshine today. It's supposed to get warmer. There we go. I like that. Other than that, adios. I'm out of here. See you tomorrow.